Welcome to finintro. This is a micro lesson on microLecture on the effective annual rate. So for most of you guys listening to this are going to be college students, and you may or may not have a credit card, but you probably know that your credit card has a stated APR, or a stated annual percentage rate. And so your APR is whatever it is, and you're probably paying some percentage. And we'll talk about that in a second. Well, there's a different calculation that we're interested in called the EAR, which stands for, as I wrote above, effective annual rate. What's the difference? The difference is that the APR is what your rate is stated at. It was what I'm going to use a credit card example here, but it is what the credit card company tells you that you're going to pay, or that you agreed to pay. And EAR is effectively what it is that you actually pay. And so what we're going to do here is we're going to run a short little future value problem and talk about this, and I'm going to give you an equation. So let's pretend for a second that you drop $1,000 present value equals $1,000 into a credit card at 12% interest for 1 year. 1 year. Let me fix this a little bit. Let me rewrite this present value. Present value is equal to $1,000. Okay. So you have over the course of a year, it's not a particularly good line, you deposit $1,000 into your credit card, and you know that we're going to ignore the fact that you make payments, right? So here's 12 months. Let's just pretend that you don't make any payments, and you calculate this out for the end of the year. How much are you going to pay? Well, this one's easy. This is $1,000 times 12% plus 1, so times 1.12, and that's going to give us $1,120. So somewhere over here, just slightly bigger than 1,000, we have $11,020. That's basically 12% over 1,000, and that's how we got that number. So let me erase this because that's not hard to do. And so we're over here, and then we draw a line that shows the growth between 1,120 and 1,000. Pretending we make no payments over the year, which credit card companies are not, that's not what they do. But pretending that there's no payments, this is going to grow into 1,120. That's at 12%. But in reality, you're compounding on a much more relative. Let's pretend that we're compounding on a monthly basis. 1, 2, 3, January, February, March, April, May, June, July, August, September, October, November, and then this one obviously is December. Our month's 12. And instead of doing one compounding for the year, which is this guy's going to compound one time on the year, we are going to compound 12 times. We're going to compound 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times we're going to compound. As we compound 12 times, we're going to break this up and use the compounding calculations that we did before. So our present value stays the same, 1,000. My interest is going to get divided by what? My interest is 12%, but I'm going to divide this by 12 because I'm calculating it monthly, and that's going to give me 1% per month. Okay? And my n, which is equal to 1 year, I'm going to multiply by 12 because I'm multiplying by 12 months, and that's going to give me 12n. So let's run a quick little future value calculation. We're going to do a quick clear all and get rid of all of the other stuff from before. Say $1,000, and I'm going to put that into my present value. And then I'm going to see, I could do the 12. I do the 12, but I'm not doing the 12 MI. I'm doing this 12 divided by 12 months, and that's going to give me 5%. So I got 12% divided by 12 months, and that equals to 1%. And then if you'll notice in the top of the calculator, I'll give you the number 1. You just hit the 1. Just plug it right into the interest rate. And here I'm doing 1 year times 12 months, and that's going to give me 12 periods, 12n right here. And so all I'm going to do is just drop that into my n right here, and that's going to give me 0 payments. And now I calculate future value. And when I calculate future value, it's going to give me 1126.82. So I owe something over here, 1126.82. Why is this number higher than this one? It's higher than that because we're running that $1,000 each month, and we're getting a little bit more interest and a little bit more interest and a little bit more interest, and it compounds on itself until I get to the end of the year. My green is my APR. This guy is my APR, my annual percentage rate. That's the number that the credit card company is telling me that I'm paying. When I go back at the end of the year and look at my actual interest and look at my return, this guy is my EAR. It's not necessarily fair that but it's something that you need to know as a financial professional. So the question then becomes, how do I calculate EAR? And so EAR is calculated relatively easily, even though the equation might look a little complicated, and it's nothing more but one. You know what? Let's not start with that. Let's start with the future value here. Let's pretend it's a future value equation. It's going to be 1 plus R to the n. Okay? So that's our future value equation, our traditional one. But we're looking for the percentage, not necessarily just the number, and there's no present value over here. So here's just my time value function. So I'm going to subtract the 1 at the end of my time value function. That's the number 1. That's not very good. That's not very good. Let's get rid of it. I'm going to subtract the number 1. How's that? Is that better? So that so that all we do is get the percentage rate. So this should look very familiar. And now I think to myself, well, this is just for that 1 year. How do I do the difference in compounding? Well, we're going to use the letter M to look at the number of compounding periods per year. All right. So if we do the one from above and we'd say that M is equal to 12 months per year, then I'm going to rewrite this equation to take into account the fact that I'm going to divide the percentage rate and I'm going to multiply the n. So my actual EAR is going to be 1 plus R divided by M to the n times M minus 1. This is my EAR calculation. And again, this doesn't need to be this looks a lot more complicated than it actually is. If you go back up here, all we did is take the interest rate, or the R or the I, and we took our interest rate and divided it by 12. In this case, M is equal to 12, and my N is 1. I multiplied it by 12. That's all this equation is saying. It's saying take the interest rate here, take the rate, the interest rate, and divide it by whatever that period is. 2 for semi-annually, 4 for quarterly, in our case 12 for monthly, and take the total number of periods, n, and multiply it by that same number. If I do that in here and take out the 1, then we get our actual EAR. So let's run this for the number above, okay? 1 plus, what was my rate? 12%, right? 12%, but I'm doing a calculation here, so I think I want to do this in decimals. 0.12. I'm going to multiply that together, and I'm going to raise that to the 1 year minus 1. But now I got to modify it for the total number of compounding periods. My M, what is M? M is 12. So I'm going to divide that by 12, and I'm going to multiply this one by 12. This is the number 1 for 1 year. Okay? So let's scroll down just a little bit more and see what happens here. So let's work it from the inside out. 12, clear all. 12.12 divided by 12 months equals 0.01. So 1 plus 0.01 to the 1 times 12. That's just simple. That's 12 minus 1. So this is, clear, 1.01. And here's my x to the y button. Everybody see this x to the y button right here? It's really small, x to the y. So I'm going to hit my orange, x to the y, 12 equals 1.126. So let's go back over here. Equals 1.1268 minus 1. is equal to minus 1 is equal to 1268. 0.1.1268. If I move the decimal, that's the same as saying 12.68%. So as you can see, my APR might be 12%, not that 12, but this 12. My APR might be 12%. Scroll down. But when I calculate this out, the actual interest that I'm paying ends up being 12.68. It's a little higher. And that is the difference between effective annual rate and annual percentage rate.